So these problems, they said on Alex that you were stuck on, or that you just needed some action similar to it. Then hopefully it will help you work through those problems. So if you look at this first one here, it says write an equation of the line below, given the y-intercept and another point. Well, if this is our y-intercept, we know that's our b in our y equals mx plus b. And so let's find our slope. Well, we need to go to the other point given. We need any other point. They gave us that point, so let's go. So we're going to go down 1, 2, 3, 4, 5, 6. So we're going to go down 6. So that's a negative. And then we're going to go to the left 1, 2, 3, 4, 5, 6, 7, 8. So that's also negative. Two negatives are going to make a positive, and that reduces down to 3/4. So the equation of our line would be y equals 3/4 x plus 3. Okay? That is one way to do it. There are multiple ways to do it. You can label the points, find your slope using the y2 minus y1 over x2 minus x1. There's so many different ways to do this equation, finding the equation of the line, but that I think is probably the quickest way to do it. Let's take a look at this one. It says, consider the line y equals x plus 6. What is the slope of a line that's parallel to this? Well, in this particular line, our slope, you don't really see it, but it's 1. So a line that is parallel to that must have the same exact slope. A line that is perpendicular to that, we can always put a whole number over 1. So we need to change its sign to a negative and flip it upside down. So flip of 1/1 is still 1/1. And so that's going to be -1. So that's parallel and perpendicular to the line they gave us. Let's look at this one. It says write equations of the horizontal and vertical lines passing through this point. Remember, a horizontal line is y equals a number. Which number? Well, it's got to be our y sitting right there, so it's y equals 7. A vertical line has to be this one. X equals a number, and the only x we see there is -4. So if you were to take a graphing utility, Desmos, something like that, and you plugged in y equals 7 and x equals -4, both of those would hit the point -4, 7, and one would be horizontal and one would be vertical. So there you go. Let's take a look at this one. It says write for each line, determine whether the slope is positive, negative, 0, or undefined. So think about my little math bug. He only looks to the right. Here he is going downhill. This is a negative slope. If my math bug is going uphill, it is a positive slope. If my math bug is on a perfectly lovely flat surface, that's 0. If my math bug is going to fall to his doom because he doesn't have sticky feet like a spider, then that is an undefined slope. Okay, so just by looking at him, that's the way you can kind of tell. Downhill is negative, uphill is positive, flat is 0, and a flat wall or something you would fall off of and slide down is undefined. It says solve the compound inequality. So this is from some of the problems from last mod. Remember, the and means a intersection. Let's solve each one individually. So I'm going to solve this first one just like normal. Subtract 1 from both sides. Divide by 2. Then I'm going to do the next one like a normal inequality. Remember, inequalities, the only thing you have to really worry about is if you multiply or divide by a negative, flip the symbol. Okay? So I'm going to add 4 to both sides. Divide by 3. or I'm sorry, divide by 4 and get 3. Now for an intersection, we want our answer to be an interval notation, so we have to draw a picture. So the numbers of importance I see are -1 and 3. Intersection, we are looking for where do they overlap. So we want to be less than -1, less than or equal to -1, but greater than or equal to 3. See how they never ever overlap. So this is going to be the null set because there is no solution. Now, if they did have a point of overlap, that is the interval you would use. But they didn't, so that's that. Let's take a look at this one. One of the things that they said you had some difficulty with in ALEKS was rearranging an equation. So let's take a look at how we would do that. So the only variable we care about is this D2. The L, the W, and the D1 needs to go away, needs to move out of the way. I think the most effective way is to initially get rid of the L by multiplying both sides by L, because that will cross that out. So we get LW equals 7 times D1 minus D2. Now, just like we multiplied by the L to get rid of it, well, we can divide off the 7 to get rid of it. So let's divide both sides by 7. So we get LW over 7, because these are going to cancel, is D1 minus D2. Now we're almost there. So now let's subtract off the D1, because I don't care about that variable. So let's take it away. Let's subtract it. So we get LW over 7 minus D1 equals the opposite, or the negative of D2. Now we don't want a negative in front there, and that's an easy fix. Just multiply both sides by -1. If we multiply by negative, the negative times the negative will make a positive. And so we're going to get negative LW over 7 plus D1 equals D2. So that is that example. Sorry about that. Let's look at this one. It says the length of a rectangle is 1 more than twice the width. So I kind of stop at that point and I take my fabulous drawing skills and I label one as L and one as W, and I say they gave me information about the length. They said it's 1 more than twice the width. So I think of twice the width plus 1 more would be that length. Now, area of a rectangle is length times width. So they told us that amount is 28. Find the dimensions of the rectangle. And so where the L is, I'm going to put 2W plus 1 times W. Now let's distribute. Now this is a quadratic, so let's get it equal to 0. Now we do that by subtracting off the 28. Okay. Now this is a perfect slide and divide sort of example. Let's take this 2, let's slide it over. So we get W squared plus W minus 56, which factors. 56 is 7 times 8. So we can do 7 would be our negative, 8 would be our positive. Now we use slide and divide. We slid over the 2, let's divide it off. Now if it divides by 2, we're good. If it doesn't divide by 2, just leave it. So what we get is 2W minus 7 and W plus 4. Now let's go ahead and actually solve each one individually. So that's 2W minus 7 equals 0, W plus 4 equals 0. Now solve them. You get 2W divided by, 2W equals 7, W equals 7 over 2, or 3.5, and it would be feet, because our units were feet. And then this is -4, which doesn't work, because you don't want a negative length. So they wanted the dimensions. We're almost done. The length was 2W's plus 1. Well, 2 times 3.5 plus 1 is 7 plus 1, or 8 feet. So if they said, what are the dimensions of this rectangle? Well, the width is 3.5 feet. The length is 8 feet. So you can say that it's 3.5 feet by 8 feet. And if you multiply those, 3.5 times 8, you do get 28. If you didn't, then somewhere along the line we made a mistake, okay? just a few more problems and then we're done. Okay. It says use the quadratic formula to solve. The quadratic formula says if you are trying to solve ax squared plus bx plus c and it equals 0, then the x is just going to be negative b plus or minus the square root of b squared minus 4ac all over 2a's. Now in this particular problem, our a is going to be 2, our b is going to be 4, our c is going to be negative 9. Let's take those values, let's plop them into the equation. So we get negative 4 plus or minus. Now the way that I like to do it is I like to actually square the b. So b squared comes next. B squared is 16. Then negative 4 times a times c is negative 4 times 2, which is negative 8, times negative 9 is plus 72. That is not 72, sorry about that. Over 2a's, now a is 2, so that'd be 4. So that'd be negative 4 plus or minus the square root of 88 over 4. 88 is divisible. The only perfect square that goes into it is 4. So that's 4 times 22, which is 2 in front of that square root. All of these are divisible by 2. That's the only way you can simplify it. So we get negative 2 plus or minus 1 square root of 20, which is just square root of 20 over 2. Don't think you can cancel out those remaining 2's because there has to be a 2 here in front of the radical, and there is not. Okay. If you tried to put this in ALEKS, you would probably have to write the answers both negative 2 plus square root of 20 over 2, negative 2 minus square root of 20 over 2 separately. I don't think they have that plus or minus option. Just a few more and then we'll be done. Here it says, write an absolute inequality given a graph on the number line. So I always check to see, is my center 0? So you see how here we have 4 units to the left and 4 units to the right. So this is the absolute value of x that is less than or equal to 4. Now it's a less than if you are the same amount of spaces for the left and the right away from 0. Okay, if it would look like this, you know, going 2 pieces, that won't be an absolute value less than, that will be an absolute value greater than. Okay. We don't need to do that one. We just did one like that. Let's take a look at this one. So this one is acting like a quadratic, but it's not quite a quadratic. Okay. So here, remember, as long as this power is double this power and that goes away, then you're probably acting like a quadratic. I'm going to use a u substitution, and I'm going to let u equal x squared. Now let's square it for a minute. U squared is x to the 4th. Double that power. So let's take out our x's and replace them with u's. So we're going to get u squared minus 4u plus 3 equals 0. Now that's just a standard quadratic. It just needs solved like a normal quadratic. So this is going to be u minus 3 and u minus 1. So u equals 3 or u equals 1. Now our original variables were not u's. They were x's. But what do we know? We know u equals x squared. So let's take out the u's and let's put in x squared. So x squared equals 3. So x will be plus or minus the square root of 3. Taking off the square, make it a square root. Don't forget the plus or minus. Here, x squared equals 1. So x equals plus or minus the square root of 1, which is just plus or minus 1. So you see we got 4 answers. It's very common if your highest power is 4 that you're going to get 4 real solutions. Now sometimes you'll get some imaginary solutions, but it's a good idea to look for, hey, I should probably get 4 answers. If you were to graph this into Desmos, just the front part, x to the 4th minus 4x squared plus 3, we're going to hit the x-axis 4 times. Positive square root of 3, negative square root of 3, positive 1, and negative 1. And that's one way to check your work. And our last example, and then I'm setting everybody free. So it says to solve this absolute value. Now, one of the keys to solving an absolute value is do not leave something added, subtracted, multiplying with the absolute value. It's called isolating the absolute value. We need it to say absolute value equals everything else. So let's subtract 5 from both sides. When we do that, we get the absolute value of 6w minus 3 equals 27. Now, once you get your absolute value ready to go, remember, an absolute value equation has two components, the positive version and the negative version. So let's set up the first case. The first case, 6w minus 3 equals 27. The second case, 6w minus 3 equals negative 27. Okay, so those are our two cases. We're going to just solve them independently. So here we add 3 to both sides. We divide by 6. Here we add 3 to both sides. We divide by 6. So we get two answers. W can equal 5. W can equal negative 4. Now, it's not a bad idea to get in the habit for absolute values to plug them back into the original equation and make sure they work. If you plug these back into the original equation, both of them work. Those are our answers. So I hope that helped you a little bit with your ALEKS stuff. And if you're stuck on any ALEKS stuff, feel free at any time to send me a text message or an email, and I would be glad to help you.